Archimedes' principle states that a fluid will exert an upward force upon an object that is equal to the weight of the fluid that is displaced by said object. Therefore, if the volume of the fluid displaced has a greater mass than the volume of the object is said to be less dense than the fluid, and it will float. It will be buoyed up by the buoyant force. The buoyant force is greater than the gravitational force. Conversely, if the volume of the fluid displaced weighs more than the object itself, then the object is said to be more dense, and the gravitational force exceeds the buoyant force, and the object sinks. So then, why does the marshmallow seem to be floating more than the orange? If they both float, shouldn't they equally be out of the water or in the water? What's different about these two? Why is this one out of water more than this one? Well, the ratio of the volume displaced to the volume of the object is proportional to the ratio of the density of the object to the density of the fluid. If the density of the object is higher, then the submersion in water is greater, but it still floats. Our teabag experiment follows the same principles. Higher density fluids will buoy up lower density fluids, even if they are the same fluid. All you have to do is make one less dense than the other. By setting fire to the teabag, we introduced a source of thermal energy to the system. This energy was transferred to the surrounding air, giving each air molecule some kinetic energy. When gases experience an increase in kinetic energy, they begin to move at a greater rate, bouncing off of each other and making them space out more than they normally would. Because molecules are not so tightly packed, they create a less dense portion of air than the surrounding air. The colder, more dense air exerts a buoyant force upon the hotter air, and the hot air floats, taking the teabag with it. This is the equation you're going to want to use for calculating buoyant force. Rho is the density of the fluid being displaced, V is the volume of the fluid displaced, and G is gravity. Buoyancy, 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 buoyancy. Okay. Okay, alright. Do you mind? Alright. Buoyancy, 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 ghost. Yeah. Buoyancy, 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 buoyancy. Ooh, dang it, dang it. No.